Assalamualaikum and hi. Today in this video we're going to talk about welding defect and distortion. Before we start our video, we would like to introduce ourselves. My name is Mak Puchari with Mohamad Safri and my metric number is 05DKM20F1023.
Hello, my name is Malcolm Oman Anak Ciro and I am holding matrix number 05DKM20F1002.
Hello, my name is Otomori Anagapo and my metric number is 05DKM20F1053.
My name is Bisan Anadayor and my matrix number is 05DKM20F1010.
A welding defect. A welding defect is any flaw that compromises the usefulness of a weldment. There is a good variety of welding defect. Crater crack. Crater crack occur when a crater is not filled before the arc is broken. This causes the outer edges of the crater to cool more quickly than the crater, which creates sufficient stresses to form a crack. Head crack. Head cracks get their name from the shape of the cross-section of the weld because the weld flares out at the face of the weld. The crack starts at the fusion line and extends up through the weld. Hot cracking. Hot cracking, also known as solidification cracking, can occur with all metals and happens in the fusion zones of a weld. To diminish the probability of this type of cracking, excess material restraint should be avoided and a proper filler material should be utilized. Underbit crack. An underbit crack, also known as a heat affected zone, has crack is a crack that forms a short distance away from the fusion line. It occurs in low alloy and high alloy steel. The other factor that affects this type of crack is internal stresses, resulting from unequal contraction between the base metal and the weld metal. That's all from me. Thank you.
So these are the 6-way prevention of welding defect. First one is use the low hydrogen filler method when possible. Take care with fit-up and joint design, pre and post weld material correctly, properly match filler metal and base material strength, implement proper filler metal storage and handling procedure, undergo the appropriate training. One of the ways that I can recommend is properly match filler metal and base material strength. Selecting appropriate filler metal strength can also help minimize the risk of weld defect. Most applications require matching the filler metal tensile or weld strength to that base of the material. The strength should be as close as possible and selected as applicable to the design's requirement of the application. If welding a low strength material to a higher strength one, always match the filler metal to the lower strength one, as it will allow for greater ductility and help mitigate the risk of cracking. When making certain fillet welds or when welding on an application requiring only partial joint penetration, it may be desirable to undermatch the strength of the filler metal to the base material. Doing so can sometimes minimize the residual stresses in the finished weld.
Next, I will talk about the welding distortion. So welding involves highly localized hitting of joint edges to fuse the material. Therefore, non-uniform stress are set up in the component because of the expansion and contraction of the heated material. Initially, the compressive stress are created in the surrounding core parent metal when the weld core is formed. However, tensive stress occurs on cooling when the constriction of the weld metal and the immediate heat affected zone is resisted by the bulk of the cold parent metal. If stress generated from the thermal expansion or contraction exceeds the yield strength of the parent metal, the localized plastic deformation of metal occurs and causes permanent distortion, permanent reduction in the component dimensions, and distorts the structure. Distortion occurs in 6 main forms. The first one is longitudinal shrinkage. The second one is transverse shrinkage, angular distortion, bowing and dishing, buckling, and twisting. Contraction of the weld area on cooling result in both transverse and longitudinal shrinkage. Non-uniform contraction to the thickness produce angular distortion in addition to longitudinal and transverse shrinkage. Longitudinal bowing in welded plates happens when the weld center is not coincident with neutral axis of the section. Twisting in the box section is caused by shear deformation at the corner joints. This caused by unequal longitudinal thermal expansion of the abutting edge.
Okay, now I will explain the method to minimize distortion. So to prevent or minimize weld distortion, methods must be used both in design and during welding to overcome the effects of the heating and cooling cycle. Shrinkage cannot be prevented, but it can be controlled. Several ways can be used to minimize distortion caused by shrinkage. Okay, the first method is proper edge preparation and fit up. By making certain the edges are properly beveled and spacing is adequate, you can restrict the effects of distortion. Additionally, you should use tack welds, especially on long joints. Tack welds should be spaced at least 12 inches apart and run approximately twice as long as the thickness of the weld. Secondly, limit the number of weld passes. You can keep distortion to a minimum by using few weld passes as possible. You should limit the number of weld passes to the number necessary to meet the requirement of the job. And thirdly, preheat the metal. To control the forces of expansion and contraction, you preheat the entire structure before welding. After the welding is complete, you allow the structure to cool slowly. Next, use jigs and fixtures. Since holding the metal in a fixed position prevents excessive movements, the use of jigs and fixtures can help prevent distortion. A jig or fixture is simply a device used to hold the metal rigidly in position during the welding. And lastly, do not overweld. The more metal placed in a joint, the greater the shrinkage forces. Correctly sizing a weld for requirements of the joint not only minimize distortion, but also save weld metal and time. The amount of weld metal in a fillet weld can be minimized by use of a flat or slightly convex bit, and in a butt joint by proper edge preparation and fit up. The excess weld metal in a highly convex bit does not increase the allowable strength in cut work, but it does increase shrinkage forces. Okay, that's all from us. Thank you.